All right, today we're going to pull back the curtain on a true legend of the computing world, the C programming language. It's a foundational piece of tech history for sure, but as you're about to see, it is far from a museum piece. Let's get right into it. I just love this quote, It perfectly sums up the whole vibe of C. It's direct, it's literal, and it really doesn't have a lot of bells and whistles. It does exactly what you tell it to do, which is both its greatest power and, well, its biggest danger. So that really brings us to the big question, right? C was invented way, way back in 1972. We've got Python, Rust, JavaScript. So why on earth would you spend your precious time learning C today? Well, the answer, as it turns out, is actually pretty compelling. Think of it like this. Modern languages have all these layers of abstraction. They're built with tons of safety features to help you out. C, on the other hand, connects you directly to the bare metal. It hands you raw power and total control. But yeah, it also comes with no seatbelts. You are 100% in charge, for better or for worse. So why is C still so relevant? Well, there are a few huge reasons. First, it's an absolutely incredible learning tool. It forces you to get your head around how computer memory really works. It's also the workhorse, the engine humming away behind the scenes, building the operating systems we use every single day. And it's the brains inside countless embedded systems, from your microwave to your car. On top of all that, you'll find bits and pieces of C's DNA in almost every modern language you can think of. So really get our hands dirty and understand C, there is no better place to start than with the most famous, the most classic program of all time, Hello World. So what we're going to do is grab a metaphorical scalpel and just dissect this thing line by line to see what makes it tick.
And here it is in all its glory. It might not look like much, but trust me, every single character you see here has a purpose. We are going to rip this thing apart and leave no mystery unsolved. So let's dive in.
Okay, first up, the easy part. See the text between the // and /* and the stuff after the //. Those are just comments. The computer completely ignores them. They're just notes left by the programmer for other humans, or, let's be honest, for their future selves, to explain what the heck the code is trying to do. Okay, this line is our first piece of real machinery. The hashtag include is what we call a directive. It's a command for a thing called the C preprocessor. It literally tells the preprocessor, hey, go find this file named stdio.h, that's the standard input-output header, and paste its entire contents right here before we do anything else. And here's a little bit of trivia for you, a fun fact. That pound sign or hash symbol, it has a proper name. It's an octothorpe. Any line in C that starts with an octothorpe is a command for that preprocessor. It's a great word, isn't it? Octothorpe. Let's just all take a second to appreciate that. Now, we're getting to the absolute heart of the program, int main void. Main is a special, magical function. It's the one and only entry point. It's the front door. When you run your program, this is where it all begins. Every single C program must have a main function, period. And these curly braces, you might hear people call them squirrely braces. They just define the beginning and the end of that main function. Everything inside these two braces is part of main. Simple as that. This line right here, this is the one that does all the work. Printf is another function, but this time we're calling it. We're telling it to do its job, and we're giving it one piece of information, the string of text we want to print. Oh, and notice that semicolon at the end? It is crucial. It marks the end of the statement, just like a period at the end of a sentence. You probably noticed that weird N at the end of the string. That doesn't actually get printed out. It's a special code for a new line character. It just tells the terminal to move the cursor down to the beginning of the next line after it prints Hello World. It's basically the code equivalent of hitting the Enter key on your keyboard. So, okay, we've dissected the code. We get what each line does. But right now, this is all just a plain old text file. So how do we transform this source code into an actual program that the computer can understand and run? This is where the magic of compilation happens. It's basically a four-step dance. First, you write your source code. Then, the preprocessor runs and takes care of that hashtag include directive for us. After that, the compiler takes all that code and translates it into machine code, the raw ones and zeros the CPU actually understands. And finally, all that creates an executable program that you can actually run. Now, to kick that whole process off on a command line, you'd use a compiler. A popular one is GCC. This command tells GCC to take our source file, hello.c, and compile it. And that little -o hello part, that's just us telling it, hey, when you're done, name the final runnable program hello. Once the compiler does its job, you'll suddenly have a new file named hello sitting in your directory, and to run it, you just type /hello. The / just tells the computer, hey, look for this program right here in the current folder. And if everything went according to plan, you will see this pop up on your screen, hello world. It's done. It's tested. Ship it. You know, it's easy to think of a language from 1972 as being sort of frozen in time, like a fossil. But C isn't a fossil at all. It is very much a living, breathing language that has kept evolving over the decades. I mean, just look at this timeline. It started with the original KNR-C. Then it was standardized with C89. C99 was this huge overhaul that added features we totally take for granted now, like those double slash comments. And more recent versions like C11 and the brand new C23 have added support for things like multi-threading and Unicode, keeping the language modern and incredibly powerful. And there you have it. From just a few lines of text to a real running program. We've seen how C gives you this direct line of communication with the machine. You now have the fundamental building block to make a computer do exactly what you want it to. So, the only question left is, what will you make it say?